I just wanted to make a video for you guys that just reminds you of a few things that we did before the break. And that's because today's lesson you're going to be learning on how to draw atoms called Bohr diagrams after the Bohr atom, Niels Bohr. All right, remember he put the electrons in orbits around the nucleus. And you're going to be drawing those atoms, and you're going to need to know how to determine how many protons are in the nucleus. And you're also going to need to know how to determine how many electrons go in those orbits. So let's review a little bit. We're going to take a look at our periodic table. And we're just going to remind ourselves of some of the features of the periodic table. Remember, we have these up and down things called groups. You can see it right on your table there. And so this is group 1. Remember, we called these the alkali metals. They were very reactive. Remember, we put some lithium in some water, and it reacted. And we put some sodium, and it reacted more. And we put some potassium, and it was really reactive. And so group 1 is the alkali metals. Group 2, remember, was the alkaline earth metals. And then in the middle, we had something that I called the transition metals. We're not going to worry about those, but they transition from being a metal to a non-metal. And then we had that stair-step line, which divides the metals from the non-metals. And then we had groups 13, 14, 15, 16. They didn't have any names. And then 17 were called the halogens. All right, they're very reactive non-metals. And then group 18 has the noble gases, which are non-reactive. And when we draw our diagrams today, you're going to learn why they're non-reactive, hopefully. Okay, so again, just as a reminder, over here on the left, we have our metals, and over here on the right, we have our non-metals. Awesome. Okay, so again, we're going to be needing to know how to determine protons and electrons. So let's clean up this chalkboard, I guess if you want to call it, and we will get our periodic table out of the way for a moment. All right, and let's zoom back in. Let's zoom back into something like potassium here. All right, so again, for potassium, remember we have two important numbers on our table. We have the atomic number, right? That was called Z. We get that from the upper left-hand corner of our box, and it tells us how many protons there are. And then we have a mass number, all right, which is called A, and that's the protons and the neutrons. Remember, the electrons are very light. They don't affect the mass very much. So let's review on how to determine those particles in there. Now I'm going to use uranium again. Now on my little periodic table, uranium's down here somewhere. I think it's in here. But I remember what the numbers are. Remember, we have U as the symbol, and we have 92 as the atomic number, and then we had 230, well, there were two forms. Remember, there was 235 and 238, so I'll write down the 235. Remember, that's the one that you would need if you want to make a bomb, but we're not going to be making any bombs. And so that bottom number, remember, is the atomic number. We called that Z for some reason, and the Z told us the number of protons. All right? It actually will also tell us the number of electrons, because remember, they're the same. They're the same for a neutral atom. They're the same thing, because they have to cancel out the positive and negative charges so that we have a neutral atom. All right, and then up here, we've got that mass number called A. There's a funny reason why they called it A. I'm not sure exactly why, but that's okay. And remember, it's the number of protons plus the number of neutrons. So if we want to know the number of neutrons, all we've got to do is subtract that number of protons away from that big number, and we will get our neutrons. So remember, the protons is the same as the little number, so we really just need to subtract that little number away from the big number. Okay, so let's go ahead and calculate our particles. So number of protons. Again, going to be important for our Bohr diagrams that you're going to do in today's lesson, and that's 92, because remember, that is the atomic number, 92. Now, if we want to determine the number of electrons, well, it's also 92, because as I wrote over here, remember, they are the same. Okay. And then finally, the number of neutrons. Again, remember, I just said moments ago, it's going to be the number of protons minus the mass number, which is again the small number minused away from the big number. So that's going to be whoops, I pushed the wrong button. Let's try that again. 235, the big number, minus 92, the little number. And I have my calculator nearby. 235 minus 92, 143 is the number of neutrons. So you're going to need to know how to do this in order to draw your Bohr diagrams, which represents an atom with the number of protons in the nucleus and the number of electrons in the orbits. All right? We really are not worried about the number of electrons, the number of neutrons, and that's because, again, remember, they're neutral, which means they don't affect the chemistry very much, but we do need to know the number of protons and electrons. All right? So that, again, is coming from our atomic number, which, again, if we zoom back out here, and maybe we make our periodic table bigger again, our atomic number are these numbers up here. All right, there they are right there, and my writing appears over top of that table. It's kind of goofy. I don't know why it does that, but that's okay. All right, so let's zoom this guy. Oh, I threw him in the garbage, but that's okay. All right, so there's a little review on how to determine your particles, and hopefully that will make your job of drawing Bohr diagrams easier. And tomorrow I'm going to show you how to draw something called Lewis diagrams. They're easier to draw, and it allows us to draw chemical compounds easier, which will be the next day. All right, we will talk to you later, and I'm going to shut off my recording. Goodbye.